So guys, welcome back to Maison African Motives. Still working on our O-level revisions. We shall try by all means to focus on the change of subject, the questions that we have up to the end, because of our time. We shall see as we are preparing, guys, for the exams. So as we know that our change of subject is basically from our normal solving of equations. If you are dealing with a normal equations, I can refer it that way as a normal equations that or a normal equation that we are used to, like we are solving for x, or we are solving for y, or we are solving for any variable that you're given. So now it's like you're solving for that variable in terms of the other variables. So you just need to work on the basics of your equations so that you understand what exactly you are referring to here. So the first part of our question, it is given, this is June 2020, question 9B of paper 2, that is paper 2 in this case. So we are given that S is equal to A over 1 minus r. Find the value of s if a is equal to 81 and r is equivalent to 1 over 3. On a condition like this, we are simply substituting. There's nothing that you're making the subject, because already the s that you're supposed to calculate is the one that is the subject of the formula. So that means in this case, we are simply going to substitute our values that we are given, the value of a in place of a. So meaning to say we are going to have 81 over, in this case, we are given 1 minus r. So this is going to be 1 minus our r, in this case, that is 1 over 3. This is paper 2, where you are given such type of a question. There's no need for us to see any explanations. In this case, you can use your calculator to simplify whatever part that you're going to have. So this was going to give us 81 over, if we subtract 1 minus 2 over 3, you are going to obtain 2 over 3 in this case. Then we can divide 81 divided to 2 over 3. That is the idea of our question. So that was going to give us 243 over 2, which is as a decimal, that is going to be 121.5. Like I said, this is paper 2. Simply substitute your values on your calculator. You obtain the answer. The first part is for the substitution. The other mark that we have there is for the answer. So meaning to say, all this whole part of our working is not even necessary. So on your calculator, you are simply substituting as it is. This is 81 over 1 minus 1 over 1 over 3, like this. So that is going to give us 121.5 in this case. So that is how we can play around this, just a matter of substituting. Then make r the subject of the formula on item 2. So from the formula that we have here, that we are given as S is equal to A over 1 minus R. We are now asked to make R the subject of the formula. That is the question. So like I said, change of subject is like a normal equation that you are solving. So it's like you are solving for R in this case, but you're solving R in terms of the other letters. That is in terms of S and in terms of A. So what you can ask yourself is, what can I do? I've got fractions. In this case, this is same as S over 1. So I can first start by clearing fractions, which is the best in this case. That is, S is going to multiply everything in 1 minus R. So it's going to be S into 1 minus R is equal to 1 times A. This is going to give us A. But as we can see, the R that you're supposed to make the subject is inside the bracket. So you're supposed to expand now the brackets by S. So that's S times 1, which is going to be S minus S times R. This is going to be SR, which is equal to A. So as we can see, we have the part here to be the subject, the part that has got R. In this case, we are referring to this part here. This is the part that has got R. So what are you going to do in this case? It carries a negative, as we can see, so you can just avoid to work with this as a negative, so you can transpose it to the other side, and then we transpose A to this side so that we avoid having this as a negative, the part that we have to make the subject. Not to say if you leave it this side, then you divide by negative, you're not going to obtain the same answer. It's fine, but avoid that term to have a negative. So meaning to say, you're going to transpose A to this side is S minus A is equal to minus SR to that side is going to be a positive. So this part that is affecting R is S. How is it affecting the multiplication? We are multiplying. So whenever you are multiplying, you're going to divide both sides. So we are going to divide by S both sides. That's we are going to remain with our R as S minus A, everything over S in this case. All right, of which you could have written this solution as in place of or instead of dividing this term only, this only term by S, we could have divided each and every term by S in this case. Here we could have divided this part by S and also this part by S. So you find out an answer such as S over S minus A over S like this, whereby this one it cancels. That is going to give us 1. So it's going to be R is equal to 1 minus A over S in this case. All right, so that is how we can have another presentation. In place of this presentation that we see here, we can have our answer in this format. That is what the question was all about. So that was our first part of the question. Let us check the other part, whereby we are given ax, the square root of ax plus b equal to d. Express x in terms of a, b, and d. All right, express x in terms of, that is, make x the subject, the formula. So given the square root of ax plus b, which is equal to d, what you have to ask yourself is, I have a square root. So how am I going to remove the square root? The opposite of the square root is the square. So you square both sides whenever you are given a square root. You square both sides to remove the square root. Remember, the square root means to the exponent of a half. So this is same as to the exponent of a half is equal to d. So how do you remove to the exponent of a half? Here you multiply by 2. So the moment you multiply by 2, here you raise to the power of 2. So the square root, same as to the exponent of a half. So a half, when multiplied to a 2, gives us a 1. So that is, we are simply removing the square root by raising to the exponent of 2. If there was a 3 here, you use 3. If there is a 5, you use 5. All right. So the moment you introduce the square, you're going to remain with ax plus b. We have removed the square root on this part, which is equal to d to the exponent of 2. So remember, what we are supposed to make the subject here, it's x. We are supposed to make x the subject. So as you can see, this part do not have anything to do with x. So we can transpose it to the other side of the equation so that it can be a negative. So ax is equal to d squared minus b. It was a positive. What is left, we are multiplying. So we divide by a, each and every term divide by a. So therefore, we are having our x as d squared minus b, everything over a in this case. All right, so that was making x the subject of the formula in this case. Then we move on to the other part, whereby we are given g is equal to the square root of h minus 4 over 5 plus h. Find g when h is 20. So this one is, we are back again to our normal substitution that we are doing in this case, whereby we are simply substituting. This is paper 1, so we have to simplify properly, to substitute everything, then simplify. We do not have calculators, remember, in paper 1. So we are given that h is equal to 20. So in place of h, you are going to substitute 20. So that's 20 minus 4. That's h minus 4. So it's going to be 20 minus 4 over 5 plus h. So this is going to be 5 plus our h, which is 20, everything under the square root. So before you simplify the square root of every number, combine these terms separately. Combine the numerator, combine the denominator. So you subtract 20 minus 4, that was going to be a 16. We add 5 plus 20 here, which is going to be 25. So now we can remove the square root, remembering that the square root of any number is a plus or minus. So we are determining the square root of 16. You determine the square root of 25, because we understand from our laws of sets that the square root of a over the square root of b is the same as the square root of a over the square root of b. So I can determine the square root of each number. Square root of 16, which is 4, the square root of 25, which is 5 in this case. So that will be 4 over 5, or as a decimal, that is going to be plus or minus 5 into 4, that is going to be 0, into 40, which is 8. So it can be 0, 8, plus or minus 0, 8, or it can be plus or minus 4 over 5. But knowing that the square root of any number is a plus or minus, that is the most important part that we are supposed to understand in this case. All right, then on the B part, you're now asked to express H in terms of G. H in terms of, that is, make H the subject of the formula. So what are we going to do in this case? We have G, which is equal to the square root of H minus 4 over 5 plus H. All right, by the way, to write 5 plus H and write H plus 5 is just one and the same thing. A plus B, B plus A is just one and the same presentation. So we are back again to that part that we talked about previously. There is a square root. So how do you remove the square root? You simply have to square both sides. This is what you need to square both sides, square both sides. So this is going to be G squared is equal to, what is the purpose of squaring both sides? It is to remove, to get rid of this square root. So you no longer have the square root. You are now left with H minus 4 over 5 plus H. Like I said, 5 plus H is same as H plus 5. So instead, we can just write this as H plus 5, which is just 1, and the same way, H plus 5. All right, so how can we make H the subject? We can't make H the subject now. We've got H on top, we've got H here. So we can clear the fractions because we've got a fraction here by cross multiplying. That means the G is going to multiply everything on this part here. So you can just open brackets to show that that is going to be G squared into H plus 5 is equal to 1. Is going to multiply everything. So it's going to be 1 into H minus 4. So 1 is multiplying everything on this side, and the same part with G squared. So G squared times H, you're going to have G squared H, G squared times 5, which is going to be 5. G squared is equal to 1 times H. Remember, that's H minus 4. What we are supposed to make the subject is H. So you consider now, after expanding and removing your fractions, removing the brackets, you've expanded now. You are now at this stage whereby you've got H here and you've got H here. On such a condition whereby the letter to be the subject is appearing twice or more than once, it's maybe 3 times or more, as long as it's more than once, we have to collect the terms containing the term to be the subject together so that you are going to apply the factorization concept. So in this case, we are going to collect these terms to one side of the equation. So I'm going to be left with G squared transpose H to that side is going to be minus H, which is equal to the rest of this part now can be transposed to the other part, because here we just need the only terms with H. All right, so meaning to say whatever term without H can be transposed to the other part of the equation. So here I do not have H on minus 4. I transpose plus 5G squared to the other side is going to be minus 5G squared. The purpose of having the terms of H on one side of the equation is so that we can factor out the common term. Whenever you've got a condition like this, you factor out the common term, which is the term to be the subject. It's not just to be a common term. It must be the term to be the subject, and the term to be the subject in this case is H. So we can factor out H. By factoring out H, we divide, meaning to say you're going to be left with G squared minus H divided by H. This is going to be -1, which is equal to minus 4 minus 5G squared. So you can now divide by the bracket. Since we need H, this is a multiplication. So this bracket, we can divide by it both sides. We divide both sides by G squared minus 1. So this can cancel. We remain with H. So therefore, we are having H as the subject. So therefore, our H is going to be given as minus 4 minus 5G squared, everything over G squared minus 1. So that is how we could have made H to be the subject. Making H the subject, we are supposed to be having H only on this side, not to say we've got H here and we also see H on this side. That is not making H the subject. It must be found on one side of the equation. And also on the transposing part, if we check on this part here, we could have transposed in different ways from this stage here, that we have G squared H plus 5G squared, which is equal to H minus 4. We could have transposed different ways. We could have taken, in this case, the G squared H to be this side, and we take the 4 to be that side, meaning to say we're going to obtain 5G squared minus 4 to the other side is going to be a plus 4. And if we take g to the other side, this part with g squared h, to where there is h here, we are supposed to obtain h minus g squared h. As long we are having the terms of h on one side of the equation, that is what is important. So we can factor out h because h is common here. So if we factor out h and h, we get 1. If we divide by h, this one cancels, we remain with minus g squared. This whole part is equal to 5g squared plus 4. So our purpose is to make h the subject. So we are going to divide by the bracket, the part that is multiplying in this case, which is the bracket. So the moment we divide by 1 minus g squared both sides, 1 minus g squared both sides, we are remaining in this case with h. So therefore, our h is going to be given as 5g squared plus 4, everything over 1 minus g squared. So the question would be like this. Someone will be asking, all right, here on our presentation, these answers are not the same. As we can see on our presentation, these answers are not the same. We took this from different calculations by changing both sides, but these answers, they represent the same thing. All right, what am I trying to say if I say these answers, they represent the same thing or they represent the same answer? Because of time, I'm just going to use a calculator to prove this to you. All right, you just take one value of g of your choice. G can be 1, you can use 0, you can use 2, whatever value of your choice. You substitute where there is g in this case, you substitute where there is g, and obtain the value of h. We must have the same answer because this is representing the same h. So let us just take one value of our choice. We can just take our g to be 1. Just any value of your choice, and you just choose any value of your choice. I'm going to start with this one, 5g squared. So it's going to be 5. We choose our g to be 1. So it's going to be 5 times 1 squared plus 4 like this, everything over 1 minus g squared, which is 1 minus, remember we said our g in this case is 1. All right, in this case, our denominator, remember our denominator cannot be a 0. So this one is not gonna work. Remember, in mathematics, denominator cannot be equal to 0. So this part of our denominator here cannot be equal to 0. So we can't use 1. We can use a 0 in this case. So let us use a 0, not 1. I didn't check this one. So let's use a 0 here. So this is going to be 1 minus g squared, which is 0 squared. So it's going to be like this. So we are going to obtain our h being a 4. We use the same value of g that we used here to find h. So we are going to use the same value of g. So I hope that part you understand that I'm explaining that denominator cannot be equal to 0. I think on our fractions, we explained about this. So I'm going to use this one, the same g, I'm substituting and see if you're going to have the same answer. Minus 4 minus 5 times g squared minus 5 times g. Remember our g is 0, so it's going to be 0 squared over g squared, which is 0 squared minus 1 like this. We are going to obtain 4. So in this case, our h is going to be a 4. As we can see, we are obtaining the same answer from different formulations or formulas that we have formulated, meaning to say these answers are the same, but only different presentations. So that is how we can test, not to say if there is one answer there, no, there's no one answer on that type of a condition. When you are given this condition, you do not have one answer. There are so many ways that you can express your answer as. All right. Let us check the other part here, whereby we are given the formula for A. So here we are given that A is equal to H into 12 plus 5B plus 12B over 2. Then we find the value of A if B is 1,5. So this is paper 2. So you can just substitute your values, then find the answer direct. Like I said, you are having calculators. So we are going to have H being equal to what? Our A is equal to H. Our H is 0,8. So we are going to have 0,8 into 12 plus our B, which is being 1,5. So that was being 1,5, everything over 2 like this. So everything is over 2. So meaning to say we are going to obtain the numerical value of A. So what are we going to do? We can simply divide here. 2 into 2, that's 1. 2 into 8, that is going to be 0,8. Sorry, it's going to be 0,4. So here it's because we are multiplying. So we can divide 2 into 0, that's 0. 2 into 8, that is going to be 4. So you're going to obtain 0.4 times. We add this part according to our body mass. We are going to add this. So we are going to obtain 13.5. So the rest you can just use your calculator, which is going to be 5.4 in this case. Like I said, this is paper 2. That's where you can also use your calculator. All right, so the first part is just substituting, then use your calculator. Item 2, express H in terms of A and B. Make H the subject of the formula. That is what you're given there. Make H the subject of the formula, given that A is equal to H into 12 plus B, everything over 2. Make H the subject of the formula. What is it that we have this time? We have got brackets, we've got fractions, and so forth. So start with fractions. Clearing of fractions is the best part before you think of the brackets. Let's think of what the fractions. So A here is same as A over 1. So we are just going to cross multiply. A multiplied by 2, and 1 is going to multiply this side. All right. So this one, I think, is just need to refresh, these applications. All right. So here we are going to have 1 multiplying to A. For this thing, we are going to obtain 2A. So you just multiply. So you're going to obtain 2A. Then we also cross multiply on this other part. So 1 is going to multiply H. Then whatever that you obtain, we multiply the other bracket. So this was going to be H, all right, into 12 plus B like this. So that is how you can clear your brackets. 2 is multiplying A, then 1 is multiplying H into the 12 minus B. The whole of this part is being affected by H in this case. So that is what we're going to have. Then from there, we can expand our brackets. So 2A is equal to, all right, so take note here, instead of even expanding our brackets, because what we want here is to make H the subject, and already H is out of the bracket. That is the only part that we have, and that is the only H that we have here on our simplification. We do not have H here. We also do not have H here. So we can simply divide by the bracket. So in this case, there was no need for us to expand. If you expand, you are going to factorize. So it's going to be another challenge there. So H was simply going to be 2A everything over 12 plus B like this. All right, so we have our H as the subject. All right, just 3 marks for that. So as you can see, change of subject, the marks, they are actually fine. We have marks which are fine. Let us check the other part of the question. In this case, we have the formula for converting a temperature in degrees centigrade, in this case, that is the degrees Celsius, is given to the temperature in degrees Fahrenheit, in this case, which is degree F. So we are given, there is a formula that we are supposed to convert, which is given as F is equal to 32 plus 9C over 5, like this. This is the formula that we are going to convert our temperatures. So the first equation is find F when C is equal to 30 degrees Celsius. In this case, find the value of C. Find the value of F when C is this. So we are simply substituting where there is C. We are going to substitute the 30, then we obtained our F. We can obtain our F. So F is going to be 32 plus 9 times C. So remember, our C we are given as 30, everything over 5 in this case. All right, so this is paper 1. So in paper 1, how do you avoid working with bigger values? Because if you multiply 9 times this 30, you are going to obtain a bigger value. So how do you avoid working with the bigger values? You can simply divide here 5 into 30, that is 6. Then you can multiply 5 times 6, which is 6 times 9, which is going to be 54 in this case. So you're going to obtain 32 plus, after multiplying 6 and 9, because these two can be combined now after you've divided. So you're going to obtain 54. You add your terms together. That way, it can be easier for us to simplify. So remember the units we are given, degree F in this case. That is how we can have our F as the as for the value when C is 30 degrees Celsius in this case. Then on the B part, make C the subject of the formula. From this formula that we are given, we are asked now to make C the subject. If F is equal to 32 plus 9c over 5. How can we make c to be the subject of the formula? Yes, we've got fractions, which is fine, but as we can see, this 32 is not even affected by c. So we can transpose this to the left-hand side so that it can be a negative this side. So f minus 32 is equal to 9c over 5 in this case. Then we can think of clearing fractions because this is same as over 1. So you can cross multiply. And for cross multiplying, if you check here, c is on this part. Here we do not have c. So the moment you cross multiply, 5 is going to multiply the whole bracket, the whole part of f minus 32. So you can just open a bracket, 5 into f minus 32 like this is equal to 1 times 9c, which is going to give us 9c. Remember, what is to be the subject is c. So here you are multiplying by 9. So you can simply divide. Instead of expanding your brackets here by 5, you can just divide by 9 both sides. As you can see, you are left with c because you are multiplying in this case. So the opposite is to divide. So therefore, we are going to have our c as a 5 into f minus 32, everything over what? Everything over 9. So that is how we could have played around this information that we are given to make c to be the subject of the formula in this case. All right, let us check the other part we are given. It is given that h is equal to mp plus half of f squared p. Calculate the value of h if m is 2, p is 3, and f is minus 4. So again, you are just, in this case, substituting. So h is going to be mp. So that is m times p. So m is 2, p is 3. So you're just multiplying m, which is 2, p, which is 3. All right. Plus half of f squared. So this is half of f squared. Our f is minus 4. So open a bracket, minus 4 squared times p. So whatever that we get here, we're going to multiply p, which is 3, or just open a bracket. Instead, we can just open a bracket times 3. So that means at the end, our h is going to be 2 times 3, which is 6, plus half of negative 4 squared. Negative 4 squared, that means negative 4 times negative 4. So at the end, this one is going to be a positive. Negative, negative, that's a positive. So 4 times 4, we are going to obtain 16. And half of 16, it's 8. 8 times 3, which is going to be 24 in this case. So 8 times 3, that is going to be 24. So if we add this part, it's going to give us 30. Or just use your calculator, since this one was for paper 2. So you can just use calculator there. Item 2, make f the subject of the formula in this case. So now we are supposed to make f the subject of the formula. So from our equation, we have got h being equal to mp plus half of f squared p. And you're asked to make f the subject. What is it that we can consider? Yes, we've got a fraction, like I said previously, but the fraction is not even affecting. I mean, this part here, we do not have f. So we can transpose this part to the other side of the equation so that we obtain h minus mp is equal to half of fp squared, like this. And also, if we are given half of a number, it simply means like half of product of terms like this. The half is affecting f and p at the same time. So we can simply remove this half here by multiplying by 2. The moment we multiply by 2, here we are going to multiply also by 2. So meaning to say we have canceled the half, and the 2 in this case will remain with a 1. So on this side, we are going to expand by 2. 2 times h, which is going to be 2h. All right. So in this case, we are supposed to make f the subject. So if we are to make f the subject, there's no need for us to expand. Yes, we can expand, but there's no need here because we do not have f here. So just leave it like that. 2 into h minus mp is equal to f squared p. Remember, we cancel the half and the 2, so we're left with p. So you can divide by p since we are multiplying. So you can divide by p both sides. At this part, we are going to be left with f squared. So meaning to say the whole of f squared is equal to this part here, which is 2 into h minus mp, everything over p. So how am I going to remain with f? I have a square. Remember, how were you removing the square root? You're introducing a square. So when given a square, to remove the square, you're going to introduce the square root, just the opposite of what we were having before. So meaning to say here, in order for us to remain with the f, we are going to introduce the square root for size. So the square root must cover everything. This whole part must be covered by the square root. So thus we are going to obtain f. So therefore, our f is going to be square root of any number is referred to as a plus or minus. Yes, in terms of change of subject, sometimes they might just mark you, but the square root of any number is supposed to be considered as a plus or minus. So you are supposed to have the plus or minus on your final answer. So like I said, due to exam pressure, this and that, they consider, even without plus or minus, they consider as a correct answer. But we are supposed to have plus or minus because we do not know the values that exist there. So that is the idea of having the plus or minus, remembering that square root of 4 is plus or minus 2. Plus or minus 2, square root of 16, it's plus or minus 4. So we're using that idea. That is why we are saying our answer is supposed to be what? A plus or minus. All right. Make x the subject of the formula. From this formula that we are given, we are asked to make x the subject of the formula. Given that r is equal to the square root of ax minus p, everything over q plus bx. Then we are asked to make x the subject of the formula. Again, if we are to consider, we have got the square root in this case. And I said whenever you are to consider terms under the square root, because the term that you are to make the subject is under the square root, and you do not have any other terms outside of the square root here on this side that are affecting. So we can think of removing that square root. How do we remove it? We have to square. The opposite of square root is to square. So you square both sides. What you have done on the right-hand side must be done also on the left-hand side. So that means here we are going to have r squared equal to the purpose of squaring. To put this square here, the purpose was to remove the square root. So meaning to say we are going to be left with ax minus p. All right, this was a small letter. You maintain capital letters and small letters. So q is a capital letter plus bx, like this. The purpose of squaring is to remove the square root. So you no longer have the square root. You are left with a fraction. And on this fraction, what is to be made the subject, which is x, is found on two terms. Here there's x, here there's also x. So how can we go about it? We have to cross multiply. We collect terms with x on one side of the equation. So here we are forced to cross multiply. So this is going to cross multiply. So that means r squared is going to multiply everything on this side. R squared into q plus bx is equal to 1 is going to multiply the whole of this part. So meaning to say we are going to have 1 into ax minus p, like this. Everything we have to consider the stages, because there is x here, there is another x there. So we can expand our brackets. R squared q plus r squared times this part, we are going to have r squared bx is equal to 1 times ax, which is going to be ax, 1 times minus p, which is going to be minus p. After expanding brackets, we are back to that condition that we had previously of collecting terms with x or to one side of the equation, where I said you can choose this term to be on this side, or we can choose this term to be on this side. This one, it's up to you, it's your choice. So let's say I decide I choose to make to collect this ax to this side. That means I'm going to transpose r squared q to the other side of the equation so that it can be a negative. So meaning to say I'm going to be left with r squared bx, transpose ax to this side, it is going to be minus ax, which is equal to what? Here we are left with already minus p. We transpose r squared q to this side, is going to be a minus because it was a positive on this side. So on the other side, it is going to carry a negative. we have the terms now of x on one side of the equation. What is the purpose? It is for us to factor out this common term, which is x. So the moment I factor out x, which is our common term, to be the subject, here I'm going to be left with r squared b. I factor out x here, I'm going to be left with minus a, which is equal to minus p minus r squared q. Once we have this bracket, we can now divide by the bracket both sides so that we remain with x, since this is a multiplication. So the moment you divide by this bracket, we are going to be left with minus p minus r squared q, everything over r squared b minus a, like since we divided by the bracket. So this is what you are going to have at the end as x being the subject. So like I said, it's going to be different to someone who chose here to transpose another way, because here, like I said, on the transposing part, you can choose to transpose this in another way. So maybe on a condition that you transposed in another way, where you chose to transpose r squared bx to this side, and you choose to transpose p to this side, you were going to obtain r squared q. You transpose minus p to this side, it was going to be a positive, which is equal to, already here, I'm having ax. I transpose r squared bx to this side. So I'm going to remain with minus r squared bx. I factor out x, which is common. I remain with minus a r squared b, which is equal to r squared q plus p. So to find x, I'm simply going to divide by the bracket a minus r squared b this side, a minus r squared b this side. So this is going to cancel. I'm remaining with x. So therefore, our x was going to be r squared q plus p over a minus r squared b. So that is another presentation, which is the same as this presentation that we see here, but just that they are different formats or different ways of showing it. All right, so that was it on the first part. Then it is given that p is equal to this formula. Make r the subject of the formula in this case. All right. So how can we make r to be the subject of the formula in this case? All right, let us consider where there's r, it's inside of the bracket. So here we can choose to divide, to expand by the bracket. It's up to you, but the easier part, let us just divide here. So we have got p, which is equal to pi w squared into r minus w over 2 in this case. So you can simply divide, because this part that is outside of the bracket, this one is not even having the term to be the subject, which is r. So we can divide by 8. So you can divide by pi w squared both sides, divide by pi w squared. So this will cancel. So that means we are going to remain with the p over pi w squared, which is equal to r minus w over 2 after dividing. What are we supposed to make the subject in this case is r. So we can simply take this term, because that is, this is the only term that has got r. So this part here, it's not even containing, we do not have r there. So you can transpose this, it becomes a negative this side. So we remain with p over pi w squared plus w over 2, which is equal to r. So as you can see, we are left with r already, r as the subject. So therefore, you can conclude that r is equal to p over pi w squared plus w over 2. That is what we can work with, simpler like that. Then after making this the subject, the question is now on the b part. Find r in terms of pi if w is equal to this. So you are now given a consideration to find in terms of pi. Already you have made r to be the subject. So you simply substitute. Yes, you can substitute on this formula, which is fine. But you can substitute here where you have already made r to be the subject. So you're going to have this as r is equal to p, which is p, which is p is 72 in this case. So we are going to have 72 over pi w squared. Our w is 6. So we are going to have 6 squared plus w over 2. So it's w, which is 6 over 2 in this case. Remember, they are saying our answer must be in terms of pi, meaning to say we must have pi on our final answer. So after substituting, we can simplify. Remember, 6 squared, it's 36. 36 into 72, that is 2. So we are going to be left with 2 over pi plus, we can cancel here, which is going to give us 2 into 6, that is a 3. So we're going to be left with 3 like this. So this can be the final answer for R. If you want to combine as a single fraction, it's up to you. You can go back to your fractions, 2 over pi plus 3 over 1. Our LCM there is pi. Pi divided by pi, that's 1 times 2, which is 2 plus pi divided by 1, that is pi times 3, which is going to be 3 pi. So the simplification there does not even matter at all. What was the question there was simply to have that as in terms of pi. All right, then the other part you're asked here to make m the subject of the formula, given that t is equal to 2 pi over 2 pi the square root of am over g, and we are asked to make m the subject of the formula. So yes, here we've got a square root, but there is a term that is outside of the square root, which is not even affected by the square root. So we can divide that term, divide by 2 pi, both sides. So we are going to remain with t over 2 pi equal to the square root of em over g. Then that's when you're going to be thinking, that's when you're going to ask yourself about removing the square root, because the term that you want m is inside of the square root, and that is the only part left on this side. So we can square both sides, we can square both sides. By squaring both sides here, every term is going to be raised to the power of 2. That's t to the power of 2, which is going to be t squared over 2 to the power of 2, which is going to be 4 pi to the power of 2, which is going to be pi squared. And this is equal to, remember, the purpose of introducing the square was to remove the square root. So you are going to be left with the em over g like this. You are now having a fraction. Once you are given a fraction, remove the fractions by cross multiplying so that we can take the term to be the subject properly. So this is going to give us g times t squared, which is gt squared is equal to, here we multiply 4 pi squared times em. So it's going to be 4 pi squared em. All right, we only have m on this side of the equation, and the rest we do not have m. So we can divide by this part. Since we are multiplying this part, we are going to remove it by what? By dividing. So we divide by what is multiplying, which is 4 pi squared e, both sides. We divide by 4 pi squared e, both sides. So this will cancel. We remain with m as the subject of the formula. So therefore, our m is going to be given as gt squared, everything over 4 pi squared e. We are now having this as the subject. That is the whole idea there. That is the whole idea of our question. All right, let us check the other part, whereby we are given when a rod of length L centimeters is being heated. All right, so we're given the rod in this case of length L centimeters, which is being heated to a temperature T degrees Celsius. It expands. This is our physics part, our science. We have this expansion or length and area. All right, so that is not the part of the question here. Our question is to make X the subject, A the subject from this formula. Make A the subject. That is the first part. Given that X is equal to L plus A LT, we are asked to make A the subject. So here we only have one term with A. So we can transpose the other terms without A to the other side of the equation, which is this L. It becomes a negative. So X minus L is equal to A LT. Remember, we want to make A the subject, and here we are multiplying. So we divide by LT both sides. We divide by LT both sides. So this will cancel. We obtain the value of A as X minus L over LT like this. All right, so that was going to be A as the subject of the formula in this case. Then let's check the B item 1. Find the value of X when L is 2, A is this. So this one is just a matter of substituting. When we are calculating X, it's best to substitute here because already X here is the subject, than to substitute here because this one is A, which is the subject. So for item A, it was best to substitute into the original formula because there x is the subject already. So we are simply substituting the value of x that we are given here. The values that we are given L, which is 2. So this is going to be 2 plus A, which is 0, 0,01 times L, which is our L is 2 times T. Our T is the temperature in which is 50. And also to take note of the units. Are they given the way they are? L is in centimeters. Here it's in centimeters, which is fine. Then X is representing centimeters. X, all right. Then T is degrees Celsius. T degrees Celsius. So these ones, they are corresponding because sometimes they might give you this one in meters. You have to convert it to centimeters because you are given that length is supposed to be in what? In centimeters there. All right, so in this case, we are going to simply apply BODMAS. This whole part is under multiplication. 2 times 50, that's a 100. 0, 0,01 times 100, that is going to be a 1. This one is going to be a 1. So we add 2 plus 1, which is going to be a 3 in this case. So that means we are going to obtain x being 3 centimeters. Remember, x is in centimeters. X must be centimeters. So whatever value of x that you are obtaining here must be in centimeters. All right. Then the item 2 is to find A when given this information. On this one, it's best to use this formula because already we have A as the subject. Yes, we can use this formula, which is fine, but it's best for us to use this one where we have made A the subject because we are saying A is equal to X minus L over LT. Already A is the subject. So we simply have to substitute our X, which is 3,1 in this case. So A is going to be, all right, so let me just substitute direct so that I do not waste this part. So we said X, which is 3,1 minus L. Our L there is 3, everything over LT. So L, remember that is 3 times our temperature, which is 40 in this case. All right, so this is what you're supposed to have at the end. So if you subtract 3,1 minus 3, that's 0,1 over here, you're going to obtain 120. So you divide properly. Actually, this was going to be endless, 0,0008 and so on and so on. So this was actually, I think was paper 1 with this value that you're obtaining. It was not corresponding because it was going to be 0,0833 and so on and so on. So, or you just have to express it as a fraction. Since the decimal part is not working, we can just have it as a fraction. Let's check the other A that we had. It was fine here. They gave us as a decimal. It was exact, but this one, it was going to give us an endless decimal. So you can have this as a fraction. How can you get rid of 0,1? We multiply by 10. Here we also multiply by 10, 1 decimal place, so that we are going to remain with 1 over 120 times 10, which is going to be 1,200. So that is what we can have as the value of A as a fraction. Since as a decimal, we are obtaining an endless decimal, it's going to be a lot. So you are going to leave it like that. All right, so that was our question on this part. Let us check the other part here. Given AX is equal to square root of B squared minus X squared, express X in terms of A and B, again, change of subject there. So we are given AX is equal to the square root of B squared minus X squared. So how can we get rid to make X the subject, express X in terms of, so here there's X here. So you don't just divide to say, I'm going to divide by A like this. Therefore, no, this is actually wrong because you are left with another X here. So you don't just divide like that. So how do we get rid of this? Because here there's X, there's another X. We can get rid of the square root because this one, there's no way for us to remove this X inside this the square root than to square so that we get rid of the square root. But here, we are going to square everything, A squared. So we're going to have A squared, X squared is equal to the square and the square root. Automatically, we are removing the square root. So meaning to say, you are going to be left with what? B squared minus X squared. You don't expand anything. No. There's no expansion that is happening there. Now we want to make x. There's x here, there's x, collect like terms. In this case, it's difficult, or yes, it's fine, but it's not that important for, it's not good or wise for you to collect this term this side, because it's going to be a negative, negative, negative. It's not wise for you to collect, but it's wiser for you to collect this term here so that it becomes a positive. Since it carries the x to be the subject, let it be a positive. So we are going to remain with a squared x squared minus x squared this side. It becomes a positive, which is equal to b squared. We want to make x the subject, yes, but as we can see, there's x here, there's x here. So factor out the common term. So if you factor out x squared, you divide this part to x squared, you remain with x squared plus x squared divided by x squared, which is 1. This is equal to b squared. What am I supposed to do? I'm supposed to be left with x, but here I'm multiplying. Yes, there's a squared. Forget about the x for now. Think about what is affecting so far this part here that is affecting indirectly our x, which is the bracket. So divide by that. Divide both sides by a squared plus 1. So that means we are going to be left with x squared is equal to b squared over a squared plus 1. At this stage, that is where now we think of removing the square, this one, the square, which is affecting x. How do you remove the square? The opposite, the square root. So here we are going to have the square root. Remember what I explained before about the square root and the square. We are going to be left with what? X. If you check, it's happening on this side, knowing that the square root of a number, yes, it's plus or minus. But if you check here, there's a single term. The square root of b squared is going to be a b. The square root and the square automatically removes each other. So we are going to be left with the b on top. But in the geometry now, we cannot consider this because this is an expression. We can't determine the square root of a squared plus 1 like this and say it's going to be a plus 1. This is wrong. We are talking about an expression, so we can't determine the square root of this direct. So it is going to remain under the square root. So it's going to be the square root of a squared plus 1. We can't determine this square root of what? Of a squared plus 1 is different from the square root of b squared. B squared is a single term. That's like the square root of x squared is a single term, this one. Unless if it was like this, unless if it was the square root of a squared plus 1 squared like this. That's where we say the square root and the square neutralizes each other. So we remain with a squared plus 1 like this. We can determine, but here we can't to say the square root of a squared plus 1. We say the square root of a squared is a, the square root of 1 is 1. This is wrong. We can't determine our square root this way. All right, so that is what we're supposed to have in this case. All right, let us check another part in this case. So here it was making x the subject. Let us check the other part whereby we are given that x is equal to aq squared plus bq squared. Express q in terms, that is, make q the subject. All right, so x is equal to a q squared plus bq squared. So if you check here, already they have the same scenario like part of our working where the q squared is common, where we just need to factor out that term because already we want to make q and it's already common here. So you can simply factor out q squared. We remain with a plus b. Like I explained previously, where there's a bracket, we can divide by that bracket both sides, divide by a plus b both sides. This will cancel, meaning to say we are remaining with the q squared. So q squared is equal to x over a plus b in this case. To find the q, since there is a square, we introduce the square root. We introduce the square root both sides. So meaning to say q is going to, can we determine the square root of x? No, we can't determine. But if it was x squared, the square root of x squared is x, not the square root of x, that is going to be x. No, 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 no. This one we can't determine. Any part we can't determine. So we just leave it under the square root as it is the square root of x over a plus b like that. But knowing that the square root of any number, it's a plus or minus. So that is what we're supposed to do on this part. Make x the subject of the formula. Again here, we can just divide here. Wx squared is equal to n. So here just divide by w by w. That means x squared is equal to n over w. Introduce the square root, just like the previous part, the square root both sides. So x is going to be plus or minus. Can we determine the square root of n? We can't. Can we determine the square root of w? We can't. So it's going to be n over w under the square root, since we can't determine their square roots in this case. All right, so that is how we can play around this one. And the other part, make u the subject of the formula given that h is equal to m into v squared minus u squared everything over 2gx. And we're asked to make u the subject, which is hidden inside of this bracket. So here we can expand our brackets, this and that, so that we can get rid of that u that is hidden in the bracket here. Look where the u squared is inside, where, so you can just remove our fractions, cross multiply 2gx times h. We are going to obtain 2gxh, which is equal to 1 times m. That is going to be m into v squared minus u squared. Yes, we can divide by m, but since we need to it's fine that we can just divide, since we do not have the part of m here. Or we can expand the brackets. So there are two ways here. We can expand brackets, or we can divide by m. So let's just introduce some other ways of calculating. So divide by m squared here. We are going to have 2gxh over m, which is equal to v squared minus u squared. So as you can see, this is the term to be the subject, the part that has got u, but it carries a negative. Avoid that term to carry negative. We do not have u on this side, so we can transpose this to the other side. It becomes a positive. Then we remove this one. We take it to the right-hand side. So meaning to say the minus u squared to the left-hand side becomes a positive. Then we take the 2gx h over m to the other side of our equation. It becomes a minus. So it's going to be minus 2gx h everything over m, of which someone could have expanded brackets in this case, all right, which is one and the same way. So as we can see, we've got u on this side. We can make it the subject by introducing the square root. The square root is covering everything. This one, it's an expression. You don't determine the square root of v squared minus. It's an expression because it's being separated by that minus. So it means our u is just going to be plus or minus the square root of whatever part that we have here, which is v squared minus 2gxh, everything over m, everything covered by the square root. That is how we could have calculated this, or we could have, like I said, expanded our brackets at this stage here, where we are given 2gxh is equal to m into v squared minus u squared. We could have expanded our brackets by m, which is going to be m v squared minus m u squared. Still, the term to be the subject here, it carries a negative, so you can transpose it to the other side of the equation so that it becomes a positive in this case. All right, sorry for that. So that it becomes a positive in this case. Like I said here, I want us to have this separate. Like I said, we had a condition where we were given 2gx, sorry for that. This is equal to m into v squared minus u squared. This is what we had. And I was saying, instead, we could have expanded the brackets instead of dividing. So we're going to obtain 2gxh, which is equal to mv squared minus mu squared. And what we're supposed to make the subject in this case, take note, is u. So we're going to make the term, because it has a negative here. We're going to take it to the other side, it becomes a negative, and we transpose this to the other side because we do not have u on this side. So that means we are going to have positive m u squared equal to mv squared. This one to the other side is going to be minus 2gxh. Since we are to make u the subject, we can divide by m, whereby you can divide each term or we can divide everything by m. It's just one and the same thing. So meaning to say our u squared is going to be equal to this. How do we remain with u? We introduce the square root. We introduce the square root both sides. So by introducing the square root, we are left with the u being equal to the plus or minus the square root of everything that you're going to be left with, which is going to be mv squared minus 2gxh everything over m. So this is another way that we could have simplified our solution in this case. Let us check another part. Given that x is equal to y plus m plus x squared, and asked to make m the subject of the formula in this case. All right, so we've got x is equal to y plus the square root of m plus x squared. Take note the term to be the subject is m, and it's inside of the square root. Yes, but we've got this part which is not even affected by the square root. So we can transpose this term to the left-hand side so that it becomes a negative. So x minus y, it would be equal to the square root of m plus x squared. Now we are left with the square root and this part, and the term that we need is inside of the square root. So we have to square both sides in order for us to remove the square root. Do not expand the brackets, just write as they are. X minus y squared is equal to m plus x squared. You can only expand these brackets if the letter that you want to be the subject maybe is involved in this bracket, but we do not have m here, so don't expand. So what we are going to do, we are simply going to transpose, since here we want m, and that is the term that we are remaining with. So we are going to transpose plus x squared to the other side of the equation so that it becomes a minus. So we are going to have x minus y squared in this bracket minus x squared, which is equal to m. So therefore, our m is going to be x minus y squared minus x squared. So this is wrong for you to say x minus y squared is x squared minus y squared. No, this is wrong. Don't expand the brackets. Even if you have to expand, that's not how you expand. You just raise everything to the power of 2. That is going to be wrong. All right, so here, just leave your answer at this stage. You have your x as the subject of the formula. On the other part, we are now given f is equal to mv minus mu over t, express m in terms of so it's another scenario that we have of a fraction. Again, we talked about a fraction. Just you have to expand your, clear your fractions. This is same as over 1. So you have to clear the fractions. Remember here we have to express m, to find m to be the subject. So expand, we are going to have ft is equal to mv, 1 times mv minus mu in this case. And m is common. There's m here, there's m. So we can factor out the common term, which is m. mv divided by m, that would be v. mu minus divided by m, that is going to be a u in this case. And here we are multiplying. So the only part to remove this bracket is to divide by it. The opposite of multiplying, that will be to divide. So that means our m in this case is going to be given as ft over v minus u. So we are now having m as subject written in terms of f, written in terms of v, written in terms of u, written in terms of t. That's what they are trying to say. Make x the subject in that manner. All right, then we are asked on the other part here, given the formula for p is equal to this part, express a in terms of, all right, so let's have our formula. P is equal to n over 2 into, so there's a major bracket there for 2a plus n minus 1 into d, like this. All right, so that is what we actually had, and we are asked to make n the subject there, make a the subject, express a in terms of, so this is where we have our a, but as you can see, it's hidden inside of the bracket. So we can play around with this part first here. What is happening here? We are multiplying by n over 2. So how do we get rid of this? We can first remove the fractions, all right? Because we've got fractions here, the 2, there, and n over 2 is a fraction. So to remove this, we simply have to multiply by 2, multiply this side by 2. To multiply here is same as we've multiplied here. That is what it simply means. So you just multiply at this point, 2 and 2 cancels. You are going to remain with the 2p. So 2p is equal to n into the bigger bracket of 2a plus the smaller bracket of n minus 1 times d. As you can check here, this n is multiplying the bracket, so we can divide by it. It's not even part of our a. There's no a on this part, so you can divide by n so that this will cancel. You remain with 2p over n, which is equal to the bracket. But here, since we have divided, there's a 1. So it's 1 times this bracket, which is going to be 2a plus 1 times this part. We are going to remain with n minus 1 times d. We want to make a to be the subject. Yes, we can clear our fractions, which is fine. We can clear our fractions, which is fine. Or you can just simply transpose, guys, this to the other side. Because this part, we do not have a on this part. So we can transpose this part to the left-hand side so that we remain with the 2p over n minus n minus 1 into d. So this is going to be equal to 2a. Since we are to make a the subject of the formula, we are supposed to divide by 2 in this case, that is multiplying. But as you can see, if we were to divide by 2 and here we divide by 2, this fraction is now having a lot that we are dealing with. It's not that proper for us. So we can just divide this one by 2 and this one by 2 so that these 2 and these 2 can cancel. Remember, on your division, this part can cancel, meaning to say we've got p over n minus this whole part of n minus 1 into d over 2, which is equal to 2, and the 2 cancels, we remain with a. So therefore, we can conclude that our a is going to be equal to p over n minus n minus 1 times d, everything over 2. So that is the whole part here over a 2. So that was what we are supposed to have at the end with our a as the subject of the formula. So many ways to deal with this part. All right, so here they want us to find the value of a. All right, is it gonna give me my information? All right, yeah, it's all right. So I have my information back. So now they are saying find the value of a when n is 10, d is 4, and p is 20. So we are simply going to substitute where we have made a the subject here. So we are given the value for p there and n, so p is 20. So that will be our item 2 in this case. So we are simply going to say a is equal to p. Remember, p is 20 over n which is 10. So our n here, that's 10. So we are going to have p 20 over 10 minus n minus 1, which is 10 minus 1 times d. So what is the value for d? D in this case, that's a 4. So we are going to multiply by a 4 in this case, all right? So that is times 4, everything over 2. So we can simplify. A is going to be this one into this one, that's a 2, minus 2 into 4, that is a 2, 10 minus 1, which is 9. So we can multiply 9 and 2, which is going to give us 18. So if we subtract 2 minus 18, that was going to give us a negative 16. This was paper 2, okay, of which is paper 2. Once you substitute, use your calculator because this is paper 2. But for just sake of simplification, maybe it was in paper 1. This is what you can do in short when you are dealing with what? When you are dealing with this type of a question. Make a the subject of the formula from this expression whereby we are given 1 over a plus 1 over b is equal to 3. And we're asked to make a the subject of the formula. This is same as over 1. So clear fractions. What is the LCM of a, b, and 1? So the LCM is ab. So you're going to multiply each and every term by the LCM. Multiply each and every term by the LCM, which is ab. So that's a, and a will cancel. You remain with b times 1, which is a b in this case, plus the b and the b will cancel. We remain with a times 1, which is a is equal to 1 into ab, that's ab, times 3, which is going to be 3ab. So as we can see, we have cleared our fraction. We want to make a the subject. And here, as we can see, there is a and there's a. So we are going back to that part of collecting terms with a on one side of the equation, depending, are you going to transpose this side or are you going to transpose this one this side? All right, so I'm going to transpose this one this side. I take the b to the other side. So meaning to say I'm going to remain with a. 3ab to this side is going to carry a negative. If I transpose b to this side, it is going to be a minus b. I'm not worried about this one to be a positive or to be a negative. I'm not worried about this because what I want is the part of A. As long my A is fine, is not affected, I can factor out my A. A and A, I remain with 1, minus A and A, I remain with minus 3B. After dividing, this one and this one cancels, which is equal to minus B. So in order for us to make A the subject, we can simply divide by the bracket, since this is the part that is affecting A now, and it's a multiplication. So we divide by 1 minus 3B both sides. By dividing by this, we are having A as minus B over 1 minus 3, which can be different ways or different formats of having these answers. As I said, all we need is to be very careful on our simplification. How are you going to simplify your questions must be clear. You must have clear presentation on your simplification. On the other part, you're given make X the subject of the formula. I think this one, there's something that we left here. There's supposed to be a P. It was Y is equal to P minus 2X. It was just a slight error on typing there. Y is equal to P minus 2x over x, like this. All right, make x the subject. So here it's same as over 1. So we can cross multiply y times x. That's why x is equal to 1 times a number. It remains as it is. So we're going to remain with the p minus 2x. We collect our terms with x to one side of the equation. So we are going to remain with yx minus 2x to this side. It becomes a positive, which is equal to p. X is common and we can factor it out. So we're going to be left with y plus 2 equal to p. Divide both sides by the bracket of y plus 2. We are going to be left with p into y plus 2 in this case. All right. So I think this one is clear from what we have done in the other part. Make k the subject from this one. Again, we can collect the terms with k to one side. So this minus bx to this side becomes a positive. So it's going to be yk plus bk is equal to ax. I want k, so I can simply factor out k here. I remain with y plus b is equal to ax. Divide by the bracket both sides of y plus b. So that means we are going to be left with k. So therefore, k is equal to ax over y plus b, or b plus y. So that is how we could have made this one the subject. On the other part here, we are now given V is given as a third pi r squared h. Express r in terms of V, pi, and h. From this part, express r in terms of this formula. So what can we do in this case, given that V is equal to a third pi r squared h? We want to make r the subject. So the 3 is there to multiply, so we can remove this 3 by multiplying by 3, since we are given a third. So the third and the 3 cancels, meaning to say you are going to be left with 3 times V, which is 3V is equal to pi r squared h. So remember here we are asked to make r the subject. So what are you going to do? We can divide by pi h both sides. We can divide by pi h both sides. So since you are multiplying, so that means r squared is going to be 3v over pi h, like this. Since we are given a square, to remove the square, we are supposed to introduce the square root in this case. So we are supposed to introduce the square root. So meaning to say, at the end, we shall have our r as plus or minus the square root of 3v over pi h in this case. So that means we have made r to be the subject of the formula in this case by using this part. Now they're saying find r if pi is this, v is this. You are just substituting your values into the formula that you are given. Already we have made r to be the subject, and all right, so here we're just going to substitute our values that we obtained. So meaning to say our r is going to be plus or minus the square root of 3 times v. So v here, that is 29 and a third. So you're supposed to express this at least as an improper fraction. So if you are to simplify, multiply here, add 1, you're going to obtain 88 over 3. This is going to be 87 plus 1, which is going to be 88 over 3. So V is going to be 88 over 3 in this case, everything over pi. Our pi in this case, it's 22 over 7. So we are going to multiply by pi, 22 over 7, everything under the square root times the height in this case, our height, which is 7. So our height in this case, that is going to be a 7. So meaning to say we are going to obtain R from there. So this numerator, simplify it on top. The denominator, simplify it separately. 3 and 3 cancels, 7 and 7 cancels. So on top, we are going to be left with the 28. So that will be square root of 88 over 22. So we can reduce by 22, 1 by 22, that is 4. So we are left with the square root of 4, whereby the square root of 4 is 2 in this case. So it's going to be plus or minus 2. For R is equal to 2, we do not know what this R is, but mathematically you can see this is the formula for a volume of a cone in this case. But in terms of our calculations, we can just leave the plus or minus, or we can just leave our answer as it is. So like I said, it's just gonna depend with how you want your answer to be like. On this part, calculate the value of A given this information. So there you are simply substituting A is equal to P, which is 350 plus PRT 350 times R, which is 5, times T it's 1.5, which is 2, plus 3 plus 1, which is 3 over 2. So it's going to be 3 over 2, everything over 100 in this case. So meaning to say our A is going to be given as 350 plus. So here we can simplify the numerator here, 2 here, that is be 1, remainder 1, into 15, that's 7, remainder 1, which is going to be 5. Then you multiply everything on top, you divide by 100 in this case, that was going to be something like 26.25. Then we add these together. So we're going to obtain 376.25. So that is the value of A from this part. Item B, item 2, make P the subject of the formula. A is equal to P plus PRT over 100. And there you are asked to make P to be the subject of the formula. What can you do? You can remove the fractions. This is same as over 1. This is same as over 1. So the LCM of 1, 1 and 100, it's 100 in this case. So we're going to multiply by 100. We multiply here by 100. We multiply here each and every term by 100. So that is going to be 100A is equal to 100P plus the 100 and the 100 cancels, that's a 1. 1 times PRT, we are going to obtain PRT. Since we are to make P the subject, we have got P to be the subject, and we have got P here, we've got P here. We are going to factor out the P, which is our common term. 100P divided by P, we remain with 100. PRT divided by P, this one cancels, we remain with RT. So you can divide by the bracket. Since we want to make P to be the subject, so we're going to divide by the bracket of 100 plus RT. So this one cancels here. We are left with P. So therefore, our P was going to be given as 100A over 100 plus RT in this case. All right, so that's P being the subject of the formula. All right, let us check the other part of the question. We are given the surface area of or solid is given by this formula, this and that. Make H to be the subject. So we can expand our brackets. We are given A is equal to 2 pi R into R plus H. So that is R plus H. So here we can expand brackets, or you can divide, because this part does not have H. Remember, I want to make H the subject, and we do not have H here. So we can simply divide by the bracket. Divide by what? By 2 pi R both sides. So meaning to say here, we are also going to divide this side by 2 pi R. This cancels here. We are left with A over 2 pi R, which is equal to R plus H. What we need is to make H the subject. So you can transpose R to this side, because H here is a positive. So it's going to be A over 2 pi R. If we transpose R to this side, it becomes a minus. which is equal to h. Not part of this fraction. It's not part of this fraction. It's separate. It's minus r on its own. So you're supposed to be careful on that part. So therefore, we are saying h is equal to a over 2 pi r like this. Whatever that we get, we subtract our r. That is how we're supposed to have our h as the subject. And after making h the subject, now they are saying find h if a is 77. So here we talked about this. This one is just going to be a normal substitution that you are going to make. H is equal to a, already is the subject, gonna 77 over 2 times pi. Our pi is 22 over 7. So it's 22 over 7 times r, in this case, our r, which is 2,5. So that is what you're going to have, minus r, which is 2,5. This is paper 2. Use your calculator at once. Take advantage of your papers. If you're in paper 2, take advantage of that. Use your calculator to simplify this whole thing that we see here. So we are going to obtain 4,9 from the whole of this part, minus 2,5. So if you subtract, you are going to obtain 2,4. So that is h, representing the height in this case of a cylinder. Don't know the units. Okay, the units there are in centimeters. So meaning to say also this h, our height is supposed to be in centimeters also. So that was the idea of our question. All right, let's move on to the other part. The temperature T degrees Celsius above the height h meters. So take note, our temperature is in degrees Celsius. H is the height in meters above sea level given by this. The first part, calculate the value of the temperature. The temperature at 4,500 meters. What represents meters? Its height. So they gave you the value of h, which is 4,500, and you're asked to find the value of t. So you're simply substituting in this case. T is equal to 20 minus h. Our h is 4,500. So it's going to be 4,500 over 150. So t is going to be 20 minus, we cancel here, 15 into 45, that is 3. 15 into 0, that's a 0. So you're going to be left with t being 20 minus 30, which is minus 10. And T represents temperature in degrees Celsius. So your answer is going to be in degrees Celsius in this case. All right, then on the other part, make H the subject of the formula, given that T is equal to 20 minus H over 150. And you're asked to make H the subject. What can we do here? We can, we only have H here. So this one is a normal part. We can just transpose this to the other side. It becomes a positive. So it's going to be H over 150 is equal to, we transpose T to this side, it becomes a negative. So it's going to be 20 minus T. We want to make H to be the subject in this case, and the part that is affecting H is this 150. So we can multiply. Since we are dividing, we are also going to multiply by 150. By multiplying by 150, we are simply making H to be the subject. So therefore, our H is going to be left as 150 times this bracket. So it's 150 into the bracket of 20 minus H. So that 20 minus T. So that was going to be the expression for H, which represents the height in meters. Now on the C part, they are saying find the height at which the temperature is. We are given the value of temperature. We are given T, and we are asked to find H. So instead of going back to the original equation, I can substitute here since I have H as the subject. So H is equal to 150 into 20 minus T. What is the value of T? Our value of T is 12. So meaning to say, we can simplify this part. So H is going to be 150 into 20 minus 12, which is 8. Then we multiply 150 times 8, we are going to obtain 1,200 in meters. Remember, H is representing the height, H meters above sea level. So it's going to be in meters in this case, this H. All right, so that is how we could have calculated our H in this case. On the other part, they are now saying, given this equation that we have, find the value of D if Q is, so here we just making, okay, you can make D the subject, or you can just even substitute as it is direct, because here we are given X as 2. So this is 2X. So 2D, we are asked to find D. So it's going to be 2D is equal to R. Our R there is -1. So it's -1 plus QX. Q is 3 times X. QX means 2 times. It's a Q times X. QX, all right? So 2D is equal to -1. This one is going to give us a 6. So we're going to be left with 2D equal to 5. If we combine this part, we can divide by 2 by 2. That means we have the value of D. So this one is going to be 2.5 or 2.5. So that is the value of D, can be 2.5, or you can write it as a 2.5 in this case. All right, so that was the first part. Then the other part was to express X in terms of D, Q, and R, meaning to say we are asked to make X the subject. So you can transpose here dx, transpose qx to this side, it becomes a minus qx is equal to, we are left with r. Since x is common, we can factor that x will remain with d minus q is equal to r. I think this part we are now used to this part here. This part x is going to be r over d minus q. So we've got x as the subject of the formula in this case. All right, the same thing, given that P is equal to this, express Q, take note Q in terms of, and where there's Q is hidden inside of the brackets. So there we are forced to expand the brackets. Remember, I was saying before, you are not going to expand brackets, but now here we are forced to expand brackets. But as you can see, this is simply a difference of 2 squares. These terms are the same. The signs are different. There's a minus, there's a plus. So it was taken from where? From x squared minus q squared. Remember your difference of 2 squares. So we are asked to make x the subject. Or you can expand. If you expand these brackets, this is what you're going to have. So if you do not know your difference of 2 squares, just expand. Just expand is normal. So after expanding, this is what you're going to have. And you ask yourself, I want to make q the subject. And this is the term with q carrying a negative. So I can transpose it this side so that it becomes a positive. So q squared is going to be x squared, transpose p to this side so that it becomes a negative. So how do I remain with q? I have to introduce the square root since there's a square. So the square root covers everything. So therefore q is going to be plus or minus the square root of whatever that we are going to obtain from this part. You do not determine the square root of x squared. This one is an expression, so you leave it like that. All right, so that is our expression. Then now they're saying take note what they are saying here, because they know that q is representing not one. They are saying find the values of q. You see now that part, because they know that you are dealing with a square root. So your answers, they are supposed to be 2, plus or minus. So now they are saying find the values of q if x is 3 and p is -7. So x is 3. So this one is just going to be a substitution. Q is equal to plus or minus the square root of x squared. Remember, our x here is 3. P is -7. So it's going to be 3 squared. 3 squared minus p. P is taken as a negative. That we are given as -7. So it's going to be minus for the formula. Then p is carrying a negative. That's how you substitute. So you can find the values of q from this, which is going to be plus or minus the square root of 3 squared. That is going to be 3 times 3, which is 9. Minus and minus, that's a plus. So this is going to give us plus or minus the square root of 16. 9 plus 7, that's 16. So q is going to be plus or minus 4. So the possible values of q that we are given is that q is going to be 4, or q is going to be a -4. So these are the values of q from knowing or from the understanding that the square root of any number is a plus or minus. So you knowing this or having this in mind, it was going to guide us now when they are asking you to calculate the possible values. I mean the two values or the values of p or whatever value that you be asked there. If you deal with the square root, there are two values that you obtain, a plus and a minus. On the other part, we are given T is equal to this, make V the subject of the formula. So here it's direct also. T is equal to 11V over 6 plus 20. So we can just transpose 20 to this side. It becomes a minus. We remain with 11V over 6. Clear fractions because this is the same as over 1. So we can cross multiply. 6, since 11V is the part with V is only one part. 6, don't expand. Just open the brackets like this, is equal to 11V. You want to find V or to make V the subject, divide by 11 since you are multiplying. So you are left with the V. So V is going to be 6 into T minus 20, everything over 11. There's no need. Yes, you can expand the brackets, but there's no need for you to do that. Now they are saying, find V when T is equal to V. They are saying T is equal to V. So where there's T here, we are going to put a V. That is what they are saying. So meaning to say, find V if T is equal to V. So we are going to have V is equal to, where there is T, we are going to put a V. So it's going to be V minus 20 over 6. So it's an equation now. As you can see, you're asked to find V. You are now left with an equation. It's no longer about change of subject. It's an equation now, but using the same basics because our change of subject is the same. Expand, cross multiply to remove the fraction. 11 times V, that's 11V is equal to 1 times 6, that's 6. So expand the bracket, 6 times V, which is 6V, 6 times minus 20, which is minus 120. Collect like terms, 6V to this side, it becomes a negative since we are dealing with an equation. So we're going to have 11V minus 6V is equal to 120. 11 minus 6, that's 5V is equal to 120. Divide by 5 both sides. So our V is going to remain as a positive. All right, there's a negative here and there's a negative there. So this one is going to be 2 here. Remainder 2 into 20, which is 24. So our V is going to be negative 24 in this case. All right, so that is what was expected of us. Yeah, 5 marks the whole question. All right, make Y the subject of the formula from this X is equal to square root of CY minus D. Make Y the subject, Y which is hidden inside of the square root, square both sides. X squared is equal to CY minus D to remove the square root. We want to make Y to be the subject. What is affecting? It's the minus D. Take it to the other side. So X squared plus D is equal to CY. How can I remain with Y? Simply divide by C both sides by C both sides. So that means Y is going to be X squared plus D over C. We have made Y to be the subject. That's it. All right, make U to be the subject of the formula again here, whereby we are given a fraction. It's a K in this case. All right, let's see. T is equal to mu squared over K minus 5mg. We are asked to make U the subject, which is this part. So here we can transpose the terms without U. Here we do not have U, so you can transpose this to the other side. It becomes a positive T plus 5mg is equal to mu squared over K. Now I can remove the fractions. This is same as over 1. So we can cross multiply. K is going to multiply everything. So it's K into T plus 5mg, which is equal to mu squared. We only have this part that is affecting, which is m multiplying. So we can divide by m both sides. So meaning to say u squared is going to be the whole of this expression of K into T plus 5mg everything over m. And what we need here is to make u to be the subject. And what is affecting is the square. Remove the square by introducing the square root. So u is going to be the plus or minus the square root of everything that we obtained here, which is K into T plus 5mg everything over m. Yes, you can multiply by K everything inside of the square root. It's up to you, but at this stage you are done. So that is how you're supposed to answer this question. It is given that R is equal to 2Q minus 5 and Q is given as 3P plus 2. Express R in terms of P. Take note, our answer here, we are given R being in terms of Q on the original question, on the original part. Now they want R in terms of P. So you ask yourself, how can you remove this P, this Q here, so that we have it in terms of, because R is supposed to be in terms of P. So we simply have to substitute the value that we are given for Q, because we are given Q in terms of P. Q is equal to 3P plus 2. So this one, it was just a matter of substituting. Then we can simplify. So R is going to be 2 times 3, which is 6P, 2 times 2, which is 4, minus 5. So R is going to give us 6P, 4 minus 5, that is minus 1. So that is what we're supposed to have as R as the subject of the formula. Then from there, given also that P is minus 3, find the numerical value of R. Already we have R as the subject here. So we are simply going to substitute back what we have. R is equal to 6 into P. Our P is given as minus 3 minus 1. So R is going to be 6 times minus 3. That's minus 18 minus 1. So R is going to be minus 19. Minus 18 minus 1, that's minus 19. All right, if X is equal to, if X over A plus Y over B is equal to 1, make X the subject of the formula in this case. All right, so there we just need to clear the fractions. As we can see, the term to be the subject is X, and it's part of the fraction. So we can transpose this side. Yes, we can choose not to clear fraction, but yeah, it's best just clear your fractions here, guys. Multiply by AB, multiply by AB, multiply by AB. Since this is same as over 1. So A and A cancels. B times X, that's BX. B and B cancels, we remain with A times Y, which is AY is equal to 1, and 1 cancels, we remain with AB. Remember, we are supposed to make X the subject. So we only have this term with X. So we can transpose this other term to the other side, so that BX is going to be given as AB minus AY in this case. We want X the subject. So B, we are going to divide by B each and every term, or you guys just divide everything by B. So therefore, our X is going to be written as AB minus AY over B, of which someone could have divided each and every term. Still one and the same thing. You can divide, still the same the answers, they represent one and the same thing. Now we are given that it is given that B is equal to a half of this, make X the subject. All right, so again we have got the square root and a number that is outside of the square root. So get rid of the numbers outside of the square root before you think of the X that is inside of the square root. So we can get rid of the 2, the half here. So how do you remove this half? Multiply by 2. But what you do must be done also on the left-hand side. So 2 times B, that is 2B is equal to this one, and this one cancels, we remain with 1. 1 times the whole of this part, meaning to say we are remaining with the square root of A squared minus X squared. Now that's where you think of removing the square root. Now we can square, since the X that we want is inside of the square root. So it's 2 squared, which is 4. B squared is equal to A squared minus X squared. That is, we have removed the square root, and we only have X here, but it's carrying a negative. So transpose it to the other side so that it becomes a positive. So X squared is equal to, we are left with A squared. We transpose 4B squared this side. So it's going to be minus 4B squared. X squared, introduce the square root to remove the squared here. So meaning to say, the moment you introduce the square root, we are left with X being equal to the plus or minus the square root. We can't determine the square root of an expression. A squared minus 4B squared is an expression, so we can't determine its square root. You just have to leave your answer like that. All right, so that is what we had. And on this part, we're given T is equal to 2 pi, the square root of D over G. Find T if pi is this. So here we're just substituting. T is equal to 2 times pi, 22 over 7 times the square root of D over G. D being 490 over G being a 10. So T was going to be equal to what? So here we can cancel square root of 49, which is plus or minus 7. So we are going to cancel 7 into plus or minus 7, that is plus or minus 1. So 2 times 22, that's 44, but our answer being a plus or minus. But for simplification, if they are not saying find the possible or find the values of t, you can write one value which is a positive on that case. But if they specify find the values of t, then you have to put the plus or minus. So in this case, we could have even left our answer at this stage is one and the same thing. Make d the subject of the formula. So we can see that we have got the square root, yes, but it's something else before. Before we think about it, we have to consider the pi, the 2 pi outside of the square root is multiplying. So we can simply divide by 2 pi. This cancels. So t over 2 pi is going to be the square root of d over g. How do I remove the square root? I have to square both sides. The moment I square both sides, I'm removing the square root. So it's t squared. Everything is raised to the power of 2. 2 to the power of 2, which is 4. Pi to the power of 2, which is pi squared, is equal to, remember, the purpose of introducing the square was to remove the square root. So you are going to be left with the d over g. All right, what are we supposed to make the subject? Remember, it's d. We are supposed to make d the subject here. So how are we going to get rid? Yes, you can clear your fractions, guys, but yes, you can see the only part affecting this d is this g, this one. So how can we get rid of this? We can multiply by g. We can multiply by g. By multiplying by g, we cancel here. We are left with d in this case. So the whole of this d is going to be, this is same as over 1. So it's g times t squared, which is gt squared over 1 times 4 pi squared is going to be 4 pi squared. So like I said, yes, you can expand your brackets, which is fine, but there was no need in this case. Actually, there's no need. All right. So okay, so that it was there was no need in this case. All right, then it is given that, as you can see, this one is similar to this question, only that here there is g, here there was l. So you see these guys, they just play around one and the same formula. Here they're asking us to find the t again, given that this, you just have to substitute this like the previous formula. So t is equal to 2 times, now you are given pi as 3,1. Always use the given pi that you have for that question. So your pi in this case was 3,1 times the square root of L. Our L in this case was 156,8 over G, which is 9,8 in this case. So if we were to simplify, this was going to be 6,2 times. If we were to divide this properly, guys, we are going to obtain a 16 in this case, and the square root of 16 being plus or minus 4. So we are going to have the plus or minus, or you cannot consider the plus or minus, like I said. So this was going to be plus or minus 248 at the end, 24,8. All right, just prove and see if it is 24,8. All right, so that is what we're supposed to obtain here. Then the next part is to make L the subject. You can see it's a repetition of the previous part where we are being asked here to make D. D and L are simply one and the same thing, as you can see. So like I said here, you can simply divide by 2 pi. So it's T over 2 pi is equal to square root of L over G. How do you remove the square? You introduce the square root, you introduce the square. So it's going to be T squared over 2 squared, which is 4 pi squared, is equal to L over G. Since last time we multiplied by G and G, we made L the subject. This time, let us do by cross multiplying. Like I said, we can also obtain this by cross multiplying. So it's G times T squared, which is going to be G T squared is equal to L times this, which is going to be 4 pi squared L. Since we want L, we are going to divide by 4 pi squared both sides, by 4 pi squared both sides. So meaning to say our L is going to be given as this formula, or this part of gt squared over 4 pi squared, just like the previous part where we calculated the value of d. Then the other part, we are given that st, given that s is equal to ut minus this, find the value of s given the information. Here we're just going to substitute the values that we are given in order for us to have s, which is equal to u times t. U is 20, so that's 20 times t, which is 2 minus half times g. Our g is given as 9,8 times t squared. Our t, which is 2, so it's going to be 2 squared. So that's s is going to be, this is paper 2, so you can just simplify direct on your calculator. This was going to give us a 40 minus the whole of this part here. We are going to obtain 2 squared, which is 4, then half of 4, which is 2. If you multiply 9,8 and 2, that was going to give you 19,6. So you subtract, that was going to be 20,4. So like I said, this is paper 2. So you can just use your calculator at once. Then the other part was to make g the subject of the formula from this part, that s is equal to ut minus half gt squared. We are asked to make g the subject of the formula. So how can we obtain g from this part here? Okay, we've got fractions, which is fine. But here you can consider also the part that has got g, it is carrying a negative. Let's avoid having a negative. So you can transpose this to the left-hand side and you transpose this to the right-hand side. So meaning to say minus is going to be a positive half gt squared, which is equal to here. We are going to be left with the ut. We transpose s to this side is going to be minus s. So in order for us to remove this half, multiply by 2, but whatever that you've done should affect each and everything on this side. So this is going to be gt squared is equal to 2 is going to multiply everything. So just open a bracket ut minus s. There's no need for us to expand the brackets because inside here there's nothing that has to do with a g. We do not have g inside. There's no g inside here, so there's no need for us to expand these brackets. No, we are left with the g on this side. What is affecting is the t squared. Divide by that t squared. Since you are multiplying, you'll be left with a g in this case. So therefore, in conclusion, we are going to have our g as 2 into that is going to be ut minus s in this case over t squared. All right, so that is what we are going to have as the subject of the formula. All we need is to revise as much of questions as we can, but that is what we had. Let's continue our revisions as we are preparing for the exams that are ahead of time. We just need to work as much question papers now as we can on YouTube. There are so many videos that we've done on question papers. Revise as much question papers as you can. That is the only way out now, to do as much practice. That's the only way out for now. But for now, that's it.